This is your ALEKS help video for ALEKS.com number 13. I'm going to go through these first few problems a little bit quickly because they are review. You've had problems similar to this in the past ALEKS.com assignments. This is a proving that two triangles are congruent. You have given information and then you end with proving that they are congruent. So just finish filling in the information from the given. Give your reason right here. That's the given. So given, fill that in from up here. And then the reflexive property, which you should know by now, it's whenever they share a side. So type in the letters for AC is congruent to AC. Then just figure out what is the reason. One trick I have is I look at the proof. I see a side, an angle, and a side, and I just want to make sure that they match up in that order. So side AB, and then angle BAC. So side here, angle here, and then the reflexive side. So it is side, angle, side. And then I would just type that in. Or actually click it from the menu, it would be side angle side. Okay, so that's how you do that proof. And then this is the one where you have to click if they're congruent or not necessarily congruent. I went through this in class, but I'll just show you one just to make sure you've got it. This is a good one, I think. So looking at this, I see one side matching up with another, or sorry, an angle and an angle with 2 marks, and then the angle with the 1 mark and the 1 mark, and the one side and the one side. So to me, they do look congruent by angle, angle, side, if I go in order A, A, S, and then I just have to finish the triangle congruent statement. So if the first one goes G, H, I, see over here what matches with G, it's K, and then J, L. K, J, L. So these are not all always congruent. I can tell that one's side angle side, and it matches here side angle side. Make sure they match. Here it's angle side, angle side. That one's not congruent, and then you won't have to do the rest of the problem. Like you won't have to fill that in. Give it a try when you're done. Check. If you have one part wrong, you can still fix it. You can also click over here to view an explanation. Okay, but that's it's review. You should kind of know how to do that one. It just helps you practice and get better. All right, another proof. We're really getting into a lot of proofs right now. So use the given information to prove two triangles are congruent. So review again. We are given a side, BC and DC. So you can kind of see how these triangles match up with their congruence. And we are given an angle as well, ABC and EDC. So this angle and that side and that side. You can fill in the first two easily because they're givens. From up here, they're given. And then there's also an angle ACB. So I'm looking right here, angle ACB and angle ECD. ECD. Well, those are special angles. You guys should know they are vertical angles, so vertical angles property. So you just have to finish filling in from the given, the reason here given, and then the last one is like how are the two triangles congruent? And it was angle, side, angle. Looking at the statements, you can also see there's two angles and one side, and that side was included in between the two the two angles. So angle, side, angle. Okay, moving on to the next one. Another proof. So this is one that you actually have to fill in, but luckily it sends it to the proof for you. So always start with the given, send that to proof. So DF and HF are congruent. So DF and HF. So I'm just going to kind of remember, I can't write on it, but I'm going to remember it's those ones. And then send to proof. So angle DEF. So I've got an angle or a side here and then an angle here. And then there's another thing I have to put before I can prove it. So I've only got a side and an angle. I am noticing I have vertical angles are congruent, so I can use these symbols. I can name at F, I have to use 3 letters. So EFD, EFD, and then I use my symbols is congruent to angle, EFD, so GFH. And the reason is vertical angles property, or vertical angles are congruent. I have to validate before I move on. So it looks good. So then I can send to proof. So I have a side at DF, side and then vertical angle, and then that angle. So it's angle, angle, side. Angle, angle, side. And I'll show you guys, I'll validate it and see if I'm right. So proof is complete. Let's check it, and it'll tell me if I'm right. It is correct. If you're missing one part, it lets you fix it. Okay. This one's really similar. If you ever see bisects, it means that it cuts it into two equal parts. So you'll just have to see, okay, so EG bisects DF. So that would make DG congruent to DF, and it gives you another side. And that's by the definition of a bisector. Let's see if I can just do it real quick. So I've got side DE. I'll have this side, and then I'll also have a reflexive side. So since EG bisects DF, I would have DG. I have to use a symbol for a segment. That one. So DG, I do the side space arrow to make the segment symbol stop. Otherwise, it keeps going and then it marks it wrong. So DG is congruent to FG. Make sure it looks like that and you don't have that symbol going forever. You have to do this like the side to the right arrow button. Anyways, that would be like something, I'm not really sure what it says here. I didn't look ahead. So it should be something like definition of a bisector. Definition of segment bisector. So that's perfect. Validate. And then I was noticing how I have a shared side. So I would have to put segment, what is it? EG. EG. Do my side arrow to make it stop doing the segment symbol is congruent to segment. Oops, I forgot congruent. Oh no. That's congruent to segment EG. Reason is reflexive property. Validate it. Now I can send to proof the triangles, and you can look at the proof. It's a side congruent, and another side. So side, side, side. SSS. I have to press validate first and then check it. And it is correct. Okay, so remember, you guys should be able to fast forward and skip if you need to. So this is new. This is the hypotenuse leg congruence property, which we learned about the other day this week. So again, hypotenuse leg, it must be a right triangle. So look for the right angle, and then the hypotenuse is across, like how that one is. So you need the H and one of the L's, and then it has to match with the other triangle. If it's a hypotenuse and a leg and a right angle, then you're good. So all you have to do is say yes or no if HL congruence can be used. On A, I see no right angle. That right away is a no. On B, I see a right angle, hypotenuse leg, right angle, hypotenuse leg, so yes. And then same question, can the HL congruence property be used? I see a right angle, and I only see the side marked, not the hypotenuse. The sides are congruent because they're the same measure, but I don't have the hypotenuse marked, so I'm going to say no. And then over here I have right angle, a leg, and a leg. They actually share the hypotenuse, which means by reflexive property that the hypotenuse is congruent. So yes, let's check it and see how I did. And it's correct. Okay, a couple more proofs and then you're done. Okay, use the given information to prove that triangle SQR is congruent to triangle QSP. So they're kind of like flipped and rotated around, I think. So anyways, this is one of the ones where you have to send to proof. We are given that they are right triangles and the right angle is marked. So if we're thinking hypotenuse leg, that's kind of where this is going. Then we also have given that PQ is congruent to RS. So look and find PQ, the bottom, and the top. Okay, so send that to proof. What I can put is how they share the diagonal. So SQ is a reflexive side, reflexive property. So SR, do the side arrow, is congruent to, oh, sorry, that's not R, that's Q. So you make sure you get the right letters because that matters. It is kind of switched around. So I'm going to say QS and I'm going to hope that that has it correct. That's reflexive property. So since the triangles are like flipped around, I'm going to switch that also. We'll see if it marks it wrong or right. All right, so at this point, I have hypotenuse and a leg and a right angle. I think that's all that I need. So I'm going to go ahead and send a proof, and I'm going to say it is the HL. We'll see if this is correct. Yay, it is. Okay, I wasn't sure about this one. So that's all you have to do. Go back and rewind if you need to see it again. All right, number 8. So I think it's another one. Oh, no. Oh, this is using CPCTC. Okay, so we did some practice in the book. This is one where you have to send a proof, send a proof. Let's see what we've got so far. I've got given ST is congruent to UT, ST, UT, two sides, well, one side on each triangle, and then RS and RU. So then I also have the shared side. So I'm going to go ahead and put in the shared side, which is TR. Side arrow to stop the segment is congruent to TR. And the reason is reflexive property. Now I've got side, 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 so I can say that the two triangles are congruent. So I'm going to use triangle symbol. I'm going to name the first one TUR, and then congruent to triangle TSR. And again, that's side, side, side. We have three sides congruent. Validate that. And now I can send a proof. Once I have the two triangles congruent, I can just say any angle, any other side that is corresponding is congruent. So CPCTC. Let's see what they call it. CPCTC. Oh, there it is. The very bottom. I didn't see it. Okay, so look to the very bottom for that one. All right, you have to validate and then you can check. And it's correct. Remember, go back and rewind if you need to, or just skip to the problems you need help with. Okay, so this is another one where I am going to have, okay, it looks like I have to prove the two triangles are congruent based on this information. And then I'm going to use CPCTC to prove a segment is congruent. So I'm going to send a proof. If F is the midpoint of segment DG, let's see, DG, F is in the middle, that by definition, so I'm thinking for the next step, I'm actually going to do the given separate because from the midpoint, I can get more information. From midpoint, I know that DF is congruent to GF. Those two sides would then be congruent because they're cut in half. Well, the big one was cut in half. So I'm going to do segment DF, DF, side arrow to make the segment thingy stop. Dang, I keep forgetting to put congruent. So congruent to GF. And that again is like, I'm looking for midpoint, probably definition of midpoint. Definition of midpoint. Okay, validate that. And then what else? Oh, then the parallel lines part. I also am noticing I have vertical angles, so I might have to use that. So far all I have for congruence is one side. So I'm going to send to proof my other given. If DE and GH are parallel, I can get congruent angles. Alternate interior angles are congruent. So I can get alt interior angles. And then, like I said, I can also get vertical angles, but I just need to get enough to prove the triangles are congruent. So I've got DF and FG. I'm thinking I can do angle, side, angle, and use the vertical angle, so ASA. So I want to plan that so that I can get it correct. So given the parallel lines, I can then say that angle HGF is congruent to HGF would be the same as EDF. EDF. And the reason would be where is it? Oh my gosh, there's a lot. Okay, so if lines are parallel, which we have, we're given lines are parallel, then alt interior angles are congruent. Okay, and then, like I was saying, there's also the vertical angles. So angle GFH is congruent to angle DFE. That's vertical angles property. So it's using all kinds of different properties from the list. I feel like I skipped it, but I don't think I did. Vertical angles. There it is. You have to search for these. Okay, so I've got a side and an angle. There it is, a side and an angle and an angle. So I was planning it out on purpose that I'd have angle, side, angle. So I'm at the point where I can now name that the triangles are congruent. So triangle GFH is congruent to triangle DFE. I can just copy the same order from up above by ASA. Validate that. And then finally, I can send to proof the last thing. So EF is right here. EF is congruent to HF because they are corresponding parts of congruent triangles. So at the very bottom, CPCTC. That's a long one. Good luck on that. I know you guys can do it. Just rewind and watch this again if you need to. And your triangles might even look different. You might have different things given. You might want to kind of skip the one you're given and find one more similar to mine. Or maybe you can give it a try. You know, maybe you don't get 100%, but you get most of the points, and that would be fine. Okay, so rewind and watch if you need to. Try your best on this assignment. Get it turned in on time. And that's the main thing, though. Make sure you guys get it done, turned in on time.